Okay, now I'm going to teach you about the velocity vector. It's Mr. Clegg again. And velocity vector, so first of all, any vector. So a vector is, first of all, I guess I need to teach you what a vector is. A vector is a quantity with both a magnitude and a direction. So a magnitude is the size of a number with the units. And the direction, well, it's a direction. It's the direction. It's shown either by an arrow or by words. So I'm going to give an example of this right now. Let's say we have a car going with a velocity of, let's just say, here's my car going with a velocity of 2 meters per second. I guess I should have, let's see here. I'm getting a little confused here. So, okay, so there's our car. It's going with a velocity of 2 meters per second. That's the magnitude. That's the magnitude. The direction could be shown by an arrow like that, or it could be shown by words such as to the east or to the right. Right, so somehow or other, the direction has to be given, either by showing words or by showing an arrow. Now, in terms of, okay, if you are drawing an arrow, then the longer the arrow is, the bigger the magnitude of the thing. So for example, I'm just going to give a few examples here. Let's see, I want to get black. Okay, so let's say I have a ladybug. Pretty soon we're going to be doing an activity with the ladybug. So let's say that's the forward direction. That's the ladybug's head, and here's the ladybug's body. So if the ladybug is going slowly, it might have a short velocity vector, but let's say the ladybug is going a little bit faster, then the velocity vector would be a lot larger. So if this were, let's say this is 2 meters per second, then if it were 4 meters per second, the arrow would be twice as long. So that's the way that works. In other words, the length of the arrow is proportional to how big the velocity is. The other thing is that the velocity vector always points in the direction that the object is moving. So this is a top view. So let's say this, we're watching from above. So here is a ladybug going to the right. Actually, I wanted to make this green. Okay, so because in our activity, the velocity vector is always a green arrow. So there is the velocity as this bug is going to the right and a little bit sort of up. And if the bug then turns around and goes this way, slowly at first, then it has a small velocity like that. And then let's say it speeds up, and a little while later, it's going up really fast. It's going to have a larger velocity vector. So that's the velocity vector. Okay, and now we're going to talk about the acceleration vector. And so the acceleration, okay, the acceleration vector is something that always, it doesn't always point in the direction the object is going, but so this one's a little more complicated. So the thing about the acceleration vector is that it points in the direction that the speed is changing. So if an object is speeding up, then the acceleration vector would be pointing forward. Okay, so okay, this is the acceleration vector. All right, the velocity vector and the acceleration vector are both going the same way, then the object is speeding up. Right? So its acceleration is positive. So the acceleration is greater than 0, it's positive. Right? So that is one situation. Another situation that we might have is if an object, let's scroll this a little, there we go. If an object is going this way, that's its velocity, but it is accelerating in the opposite way. Oops, trying to get it to go, there we go. And it's accelerating in the opposite direction as the velocity, then the object is slowing down. And so we also say in this situation, the acceleration is going to be less than 0. And so the acceleration is negative. All right. Third situation that we might have that we're not going to do numbers for, but we're just going to describe a little bit, is if an object like a ladybug is going this way, whoops, if its acceleration is to the side, then it is turning. And so the object is turning. So you're going to have a chance to explore this in the Jamboard that you're about to do. So the Jamboard links to an activity that you can do, a simulation online, and then it has a lot of questions that you have to answer. And the idea is I want you to do those questions in your own Jamboard, but talk about them too with people at your table so you can both explore this activity together. All right, that's all I got for you now. Have fun with this assignment, and I'll check in with you soon.